Oh, it's going. Right. So this is the same paper, June 2010, Core 4, question 3. Good to make eye contact with the camera. Right, express it in partial fractions. Now, again, this is one of the things that we must remember with this. When you split these up, it doesn't necessarily matter why it works in this way, but when you split up the fraction, you take brackets, and you make this as being, let's work through it, you make this as being, it's obvious, isn't it, that we're going to have something over x minus 1 squared, and we're going to have something over x minus 2, because that's what it must have been, to have a common denominator of that. But if one of the brackets is squared on the bottom, you have to have that as a single bracket as well. So this we're going to write as a over x minus 1 squared plus b over x minus 1 plus c over x minus 2. And it's just going to be the case that you must just remember that if you have a squared bracket on the bottom of your fraction, you need to have it both in squared form and as a single bracket when you expand the partial fractions. And it's because if we were to put this over a common denominator, that would be the common denominator. The smallest thing that all three of these expressions go into is x minus 1 squared, x minus 2. So that's why we have to have all three of that. It feels a bit weird having that one. Potentially, b could be 0. A and C won't be 0, but B could be, because this bracket doesn't actually have to be there, but we have to check that it's not 0. The other thing is, it doesn't matter what order you put these in, so we could have put these denominators in any order that we wanted to. Okay. The next stage, which you maybe don't need to write out in complete detail, is you multiply both sides by the bottom line. And if you did that, you'd be left with an x squared on the left. And if we think through, if we multiplied by x minus 1 squared, x minus 2, the x minus 1 squares would cancel out, and we'd be left with a times x minus 2. In this expression here, what we've got, if we multiplied by x minus 1 squared, x minus 2, I'm sorry, that's not working at all, is it? If we did that, then I wish I had done that. Then it's just gone. I was just trying to make a point. If we multiply by that bit, can you see what would happen with this one? The x minus 1 would cancel out with one of those x minus 1s, and so we'd still have x minus 1, x minus 2 multiplying b. Okay? Let's get rid of that one. So here we have b times x minus 1, x minus 2. And finally over here, if we multiply this, you'd have the x minus 1 squared, x minus 2 at the top. The x minus 2 cancels out, and we've got c times x minus 1 squared there. Are we all happy that that's what we end up with when we work it through? The next job is to try and solve this. Now, there are a few ways that you go at this, and I'm not exactly sure how Graham and Steve teach this. Well, you could just pick any three values. As long as you pick three different values of x and sub them in, you'll get three simultaneous equations that you then need to solve. But you can make that job a lot simpler by choosing particular numbers. So if we choose, say, x minus 1 as being significant, that would mean x would be equal to 1, because that makes that bracket 0. So if we choose x equals 1, then we would get 1 squared over there. We'd get a times 1 minus 2. We'd get b times 0 times minus 1, so that's 0. And we get c times 0 squared, so that's 0. So we get a equals minus 1 after that very quickly. And the same thing happens if we choose x as being 2. If we throw x equals 2 into that, then that one disappears. And that expression disappears because we've got 0 in there. And here we've got 2 minus 1 squared. So we've got 4, 2 squared is 1 times c. So quite quickly we end up with c being 4. Now at this point, because it was a squared bracket, there isn't a third number to throw in there to get rid of the other expression. So we just have to go with a simple value of x, as simple as we can think. Sometimes you'd use 1 at this stage, because 1's pretty simple to deal with. We've already used 1. 0 seems like a fairly simple value to sub in. If we put 0 in there, we get 0 on the left, and we get minus 2a. We get minus 1 times minus 2, so that's 2b. And we get minus 1 squared, so that's plus 1 times c. Except we already know what a and c are, and so we just sub those in, and we've got, what, 2 plus 2b plus 4, and so out of this I think we get b as being minus 3. And in this case, that was, I think, all that we had to do, wasn't it? We just had to express it in partial fractions. So to finish off our answer, we need to say x squared over, what was it? X minus 1 squared, x minus 2 is, and what order have we said? A over x minus 1 squared. Now, I think I'm going to start with the c term, because that's the positive one. So we've got c over x minus 2, that's 4 over x minus 2. And then we had a over x minus 1 squared, so that's minus 1 over x minus 1 squared. And then we had minus 3 over x minus 1, and it looks like that. And again, this was quite a gentle start to this paper, because that was another 5 marks. And that was it. You didn't have to go on and integrate it or anything else.